All right, we're back with Chapter 10 and how we can keep the bad guys out of what we're doing. Okay, so for today, we're going to do a quick review again, looking at what we've already talked about and where this fits into the big picture. And basically, we're going to be taking a look at Chapter 10, which deals with a lot of different issues, including securing your communication channel, looking at different client-side security issues, and then server-side security issues. And then lastly, we'll briefly touch on how you can recover once a major disaster has happened. So let's first start with the review. So, this is the same model we've seen the last few review sessions. And, we've talked about the Internet Foundation and, what the Internet is based on, its history. You got to have TCP/IP for all this to work. And then we have a web server built on top of that where we're dishing out our server content, which includes all the HTML pages, the PHP pages, cascading style sheets, JavaScript. All of them are coming from the web server. However you configure that to give it off to the users. That all is what's encompassed within the website itself. Okay, so we talked about e-commerce software in a previous chapter. And then what do we do with all this e-commerce software? Well, we have revenue sources. We create a web presence. We use various advanced technologies to enhance what we're doing. And we do that to support our marketing and B2B efforts. And all this is wrapped, again, in our legal and ethical environment. So what are we talking about this time? Well, we're actually going to go back to one of the previous pieces, the web server. And we're going to spend a little bit more time looking at not just, we talked about the basic setup, but now we're going to deal with how can we be more specific about setting up the web server to prevent bad people from accessing our information, from breaking our system, to doing anything that interrupts what we want to do. In other words, they're screwing with our property, and we want them to stop, right? You remember that, right? The private property thing? We want them to not screw with it, to not interrupt it, to not violate our right to our own liberty and property to do what we want with our server. So let's start by looking at client-side security. So as web developers, keep this in mind that even if you're doing lots of web development, so you think you're going to work with mostly the server-side issues, the fact of the matter is all of your friends and family are going to come to you to ask you for questions about how does a certain technology work. So whenever you're talking about client-side security, people are going to come to you and ask you questions. And that's going to be a large basis on how well people interpret your knowledge and skills in this area, because they don't really know of anything else. So having good answers for this can really help you present yourself as a very intelligent and capable person in this genre. So you're going to be educating others on how web security protects their information. In other words, you want to build trust by showing them how we're protecting your information and understanding how these common web practices all fit in together to creating this secure system that they can trust. Okay? So understanding how these pieces all fit is absolutely essential. And one of the biggest issues you need to understand is how we can protect or secure the channel of communication. So for example, there's something out there called a sniffer. Okay, I don't know if you guys have heard this term before. What is a sniffer? A sniffer is essentially a piece of software that can read data that's crossing the internet. So it sniffs for things that are being transmitted. What types of things are being transmitted that it's sniffing for? Generally two big things: your user ID and your password. The password being the most important of those. That's the one you want to try to protect. Now, these can be installed in many different places, and people won't even necessarily know about it. Now, hopefully you have some good software, security software that can find these and delete them. But they could be installed sometimes maliciously, sometimes even by your ISP technically could do it. to see what you're doing. Okay? So we need a way when we're transmitting information across the internet to secure that information so that a sniffer, if one is installed, can't see what's being transmitted. Because they can see a series of ones and zeros and interpret that as back into digits, so it could read a password if it's not secured. Well, to prevent this, we need to encrypt our messages. Okay? Now, not everything that's being sent over the internet needs to be encrypted. Usually only a small segment of stuff like passwords. Most of the text on most pages, nobody cares if it's encrypted for the simple reason that it's supposed to be public. So you want people to be able to see it. There's no reason to encrypt that. All right, but when we do want to encrypt it, today we use it's standard 128-bit encryption, which essentially means they use 128 ones and zeros as a key that describes how to encrypt and how to decrypt a message. And it's based on a specific algorithm. So an algorithm is like a big, fancy algebra problem. All right, that's the best way to think of it. Is an algebra problem is what an algorithm is. And you need to know the key, and the keys are up to 128 bits. So why 128? 128 is a large enough number that in order to randomly guess what that number is would take an extremely long period of time, even with the most advanced computers today. Okay? In other words, you want a key that's long enough that, let's say, a supercomputer today would still take days, weeks, months, maybe even years until they can randomly guess all the different variations of that key until they actually find the right key for your encrypted message. Okay? This is generally done using a public-private key encryption scheme, and we'll talk just about that in just a minute, how that can be accomplished. Okay? And using what's called SSL, Secure Sockets Layer, and HTTPS. HTTPS. Essentially, you've heard of HTTP, Hypertext Transfer Protocol. Now we're making it secure. That's what the S stands for. All right, so let's dig into this a little more. When you go into a browser, sometimes what you're going to notice is that there is an HTTPS on it. So here's a look at the URL. You'll see HTTPS. And as you scroll across, you'll also see what looks like a lock, like a padlock. And after it says DFS service. Okay, that is telling us that this particular website, discovercard.com, has been secured, and information being transmitted across this is encrypted. So your personal financial information from the Discover card cannot be read by a sniffer. All they're going to see, all a sniffer would see would be a bunch of random ones and zeros, and so they couldn't make any sense out of it. So that's where the HTTPS fits into this. Right? So let's look at the public-private key encryption. So essentially what we're doing here is we have to have a way of, when we want information. So take Discover Card example. Discover Card has to provide its users with a key to decrypt the message, but it also has to have something on the server side, their server, that allows them to encrypt it and then send it to the user to be able to decrypt it. And it's called the public-private key encryption that allows this to happen. So let's say, for example, me as a user of Discover Card types into the browser. So I'm the SSL client. Okay, I send a message to Discover Card saying, "Hello, I want to see some stuff." And basically it says send encryption algorithm key length. And that's my first message I send to Discover Card. Discover Card responds with the hello message and sends a server certificate containing the server's public key. Okay? So now I have their key The client responds, so my computer responds, sends another message back saying send client certificate and encrypted private session key. And then the server receives the client response and initiates the session. Okay, so I send them the private key based off of the public key, but it can only be, the private key has to be sent every single time I send a message so that they know that I'm always the one who's looking at this information. Then it creates a session. So you see it goes down to initiate sessions. And at the very bottom there's a session that's basically sends data between the client and server using the private shared key. Okay? So essentially, the public key is created by the server. So in this case, Discover Card. It's shared with everyone who wants to create a secure session. The public key helps define the private key that's then just used for the client interacting with the server for a specific session. And so you can have multiple sessions with multiple different private keys. So that's the kind of the basic key. And I don't want to get too much more detail into how this works, because it can get very complicated real quick. But that's basically how it works here. So you're basically sharing these encrypted keys, so that way when we send messages, they're always encrypted. They can be decrypted at the other end based upon the public or private keys that have been shared with each other. Nobody else in between can read it. Even other people who might have created their own session with Discover Card or whoever the SSL server is. All right. So how can we detect malicious websites? So let's say discovercard.com. We know them, we trust them, right? Well, what's to stop another company to come up with, say, to make a fictitious website called thenewdiscovercard.com? Okay? How can we trust this website to be the real website? Is it discovercard.com or is it thenewdiscovercard.com? And it may be very difficult from a user standpoint to know which one it is. And that's where this idea of digital certificates comes in. Okay. Websites or companies can file for a digital certificate, which basically provide a certification of authority. It certifies your company as the owner of this website. It verifies the owner's identity, the owner's public encryption key, the dates that it's valid, and even more information. Right? And this allows you to, when you create this connection, the session, to know who you're working with, if you want to. So going back to our URL, you can see this as you look across. You'll see where it says DFS service. Okay. I put my mouse over this, and it showed a little box that popped up underneath of it. It says identified by VeriSign. Click for more information. I click on it, and this is what it shows: the certificate information. So in this case, the certificate was intended for the following purposes: ensures the identity of a remote computer, says who is issued to, issued by, valid from 10/25/2011 to 10/26/2012. Now, Discover Card obviously is going to have to renew the certificate before October 26th. Okay, that's going to be handled internally. But that's how it's accomplished. And now I can see that, okay, this was issued to discovercard.com. If I want to see more information about that, I can click on the issuer statement and verify the authority. It's actually the company, Discover Card, that created this website and is someone who I can trust to send information to. All right. So this is getting into the really nitty-gritty of how do we create this. Now, this is really, really important whenever you're doing any type of secure transactions, any type of transaction where people type in passwords, type in credit card numbers, any of these things where you want to establish that they have a secure channel, that their information will not be read anywhere along the path. Okay, so any type of e-commerce transaction where money is changing hands online, you want to kind of create this type of channel, which means you need to go. It's ideal. You don't have to, but people will naturally be very hesitant to use these services if there's no certificate that verifies that they're legit. Okay. All right. So that's how you can protect your channel. Now let's go look at something else on the client side, is understanding malicious content. And I think there's a lot of misinformation thrown around here. So let me try to break this down a little bit. Now, there is possible to have malicious web page content. I'm not going to say that there isn't, but here's some of the things I talk about in the book and where I think they overplay it a bit and where they're all right. Cookies. Now, a lot of people like to talk about how cookies are this horrible thing, that they cause all kinds of problems if you allow people to have cookies on through your browser. Usually not. Cookies themselves, the way it's designed within most browsers is that it's what's called a sandbox. So you can save cookies to a very small area. Inside the cookies, there's nothing it can do to access the rest of your computer. Really the dangerous part of it is non-existent to the actual computer itself. What can raise a problem is any privacy issues. And that might arise from, for example, if you have a cookie that can be shared between multiple websites. Now, generally, this is frowned upon. In fact, if you have any type of security software, it will search for cookies that do this, and it will recommend that you delete them. I don't think it's necessarily a bad thing to have those types of cookies. You just have to realize that the privacy expectations of that people know that you went to this, and this different website may go away if you don't delete those cookies. It's not saying that it does it for a cookie can only be used in cooperation with other websites. I don't know if that makes sense to you. So in other words, a cookie, in order to put a cookie or to use a cookie, you have to know what the cookie name is. You have to know, you have to have code to work with it. Well, do you know, there's the third thing. The cookie is limited by who can write and edit it. They have to have some sort of shared server connection in order to use a specific cookie. So, for example, if I go to Facebook and it stores a cookie, it doesn't mean that my website can use that Facebook cookie unless I've set something up previously to work with it. And that's probably a very poor analogy, but it's the best I can come up with. Okay. Generally speaking, though, it's not a major issue. All right. There can be much bigger issues with various plugins, whether it's ActiveX, Java Applets, Flash, Silverlight. Some of them aren't necessarily malicious. Some are just really poorly designed. So I've had various Flash applications open that crashed my browser. It started sucking up all the resources on my computer. And not necessarily malicious. It was just there's a memory leak, and it causes problems. But you can actually create some of these that start to interact with your computing system itself. And that's where things get a bit more dangerous. So, for example, some ActiveX applications can access your computer. And you might install this plugin or add-on not realizing how it's interacting with your computer. And that's where things can get a little bit hairy as far as what can it access, what can it do. For example, when we use Blackboard Collaborate, you have to install Java. And it opens a window. And so it's an internet-based window, right? But you're assuming, and it uses your microphone, it uses your camera. So it's accessing resources on your computer, but it's still being displayed through the internet. Do you guys see any problems with that potentially? Well, yeah, there can be. So these are far more dangerous. And the best word of advice there is be hesitant to just install any type of plugin that you find on the internet. Be sure it's coming from vendors that you can trust. All right. JavaScript, it's not dangerous. And the book tries to talk about how it is, but they don't give any examples. Why don't they give any examples? Because it's really not that dangerous. The worst it can do is create something like an infinite loop, which basically means your web page will crash. Or the worst, especially if you have an older browser, maybe the browser gets locked up. Okay. Nothing serious that they can do. Okay. It's kind of like cookies in that they're in their own little sandbox, their own little closed off area, and can't access any of your computer resources. So there's really not anything that you have to be worried about. Now, not just, and we'll talk briefly about the malicious emails as well. Yes, your email can be malicious if you send attachments with your email. Email in and of itself isn't malicious, although people can send nasty messages in an email. Usually when we talk about malicious email, we talk about attachments that can cause problems. So there's things called viruses, worms, Trojan horses, and even phishing. Okay, and you guys know the differences between those. If you don't, look them up. Okay, read about them. Now I can give you a brief definition, but until you look at it a little bit more on your own, my brief definition isn't going to go very far. All right. So make that one of your little assignments. What's the difference between these? Virus, worm, Trojan horse, and phishing. So my brief definitions: a virus is essentially like an attachment. It can only exist when it's attached to something else. And so it's a very apt to be related to email in that emails can have attachments, which can be viruses. And there's been several of them that have been very, very malicious. Now, things seem to have gotten better in the last 5 or so years. I haven't really seen a lot of viruses infecting computers in any of the workplaces where I've been at. Some bad ones in the past that I remember was like the I love you virus, which was, I think, around 1999. It literally brought down thousands of email servers throughout the world. And it basically worked. If you ran Microsoft Outlook, you got an email, you open that email, automatically the virus would check for all of your contacts in Outlook, send each one of those contacts an email with a little message and itself attached, basically saying, I love you. Okay? So all these people see this email pop up in their Outlook. They click on it thinking their friends, whoever's a contact, that sent them this email, says, I love you. They're going to open it up to see what it's saying. And people kept opening them, and it literally overwhelmed thousands and thousands of email servers throughout the world. A lot of businesses spent a lot of money trying to clean that up. So what's a worm? A worm, and here's where some of the confusion can come in. A worm can be a virus. So some worms can be viruses. Not all viruses are worms, and not all worms are viruses. A worm actually opens up a connection between two computers to send information. Generally what happens with these is they find a way, a hole, a bug, or an opening through different computers that it can connect to and send information. A Trojan horse, oftentimes, and not to be confused with a virus, a Trojan horse is a small piece of software that, let me rephrase that, is a application that looks good, looks normal, looks to be valid, but when you download it, actually has some malicious code in it. Okay, so it's based off of the idea after the Greek story of the Trojan horse, where the Greeks were attacking the city of Troy. At one point, the Greeks said, hey, we're going to stop the battle and leave. We're going to give you a gift of this gigantic wooden horse. And they roll it up to the gate and they walk away and pretend like they were leaving. The Trojans bring the horse into the city. That night, what was inside the horse was a bunch of Greek warriors who escaped from the horse, opened the front gates, the army poured in through the front gates and destroyed the city of Troy. Great story, right? So the idea of a Trojan horse is a piece of software that looks nice, like a big horse, okay? But inside of it is some very malicious stuff, okay? And, this could be something, you go out to a website, you say, oh, look, they got maybe a peer-to-peer file sharing service. Oh, that's great. That's what I want. You download it. It looks normal. It works normal. But behind the scenes, there's some nefarious stuff going on, such as there's a sniffer who might be reading all your keystrokes as you're typing in logins and passwords. And then it sends that information off to some server where there's a hacker who's collecting all these names and passwords to use for whatever they want. All right, the last one, phishing, is the concept of sending you an email with content that looks like a legitimate email, but really isn't. And oftentimes they use this to say, go to this website to update your information, or your account has been hacked, you have to go to this website to reestablish your account. Okay? You may have seen some of these before and thought, well, this is an odd email. If it looks odd, don't do it. Most businesses now like it. Yeah, I've even seen these for ECU, basically saying your ECU account has been hacked or has been compromised. Please go to this website, and they'll have a link. You click on the link, it takes you to a web page where you enter in like your username and your password. Well, what they're doing is trying to capture your username and password. The website itself is not a legitimate website associated with the email that was sent. It's owned by somebody else, and that somebody else sent the email pretending to be the legitimate company. All right. So how do we fix these problems? Well, today we have junk mail and spam filters that generally work by looking for common patterns that don't seem correct. Okay, so it's a pattern-based system. So it might look for certain key terms, like if there's penis enlargement, or those are really big spams that were being sent around. I don't know if any of you guys have gotten any of those, or maybe the little newish drug that's someone's trying to market. So look for key terms like those. And once it finds those key terms, it sends it to the spam box. And so they're not perfect, but they're getting better at finding spam. Okay, so it's good to always occasionally go through your spam, everything in your spam box, to check to make sure nothing legit has accidentally been sent there that shouldn't be. I used to be much better at this. Lately, I haven't checked in the last 6 months, but it used to be about once a month I would go and look to see if anything legit has been put into the spam filter. But that's all they're doing. Is they got an algorithm that checks for certain trends that don't seem correct. All right. And that's all we're going to talk about in the client-side security. So let's move on to server-side. So 3 big things: password, database, and then the overwhelmed server. And then lastly, general server security issues on the server. And then after that, we'll get into how to recover from those issues. But the first 3 are specific for internet technologies. The 4th one is just general server security issues. All right, so the first one's password security. And well, actually, this is applicable beyond just internet, but important enough because you use a lot of passwords online. Tons of passwords and tons of different websites. So one common method of finding out people's password is using something called a dictionary attack. And hackers that want to try to break into websites will oftentimes use these. Now, you think about the passwords that people commonly use, and you might say, well, I'm going to use the password of, ECU business student, okay? You think, oh, that's pretty unique. Who's going to have that? Well, if you use something like a dictionary attack, you can put in acronyms like ECU. You can put in various words like business and student, and then try randomly putting these together and sending it to a website to see if that's the correct password or not. And you can do thousands of these, millions of these every minute. Okay? Thousands every second, millions every minute. And if you have a really powerful computer, you can try even more. You can also try certain combinations of numbers of special characters that are often used. So how many words are in a dictionary? You might have 10,000. We'll say there's even 100,000. How hard is it to try 100,000 different words as a password? Maybe a combination of those. So maybe we have some common combinations of those. It's going to take a few minutes to try all these, but computers are pretty damn fast, right? How many passwords are based on words in the dictionary? Right? How quickly can an automated application test 1 billion passwords to log on into a server? Stop and think about that. How long would it take? Well, if you have a pretty powerful computer, pretty quickly, and a pretty strong internet connection, guess what? You can probably have that done within 10 seconds. Okay? 1 billion passwords. It doesn't take long to test that much. All right? So what you want to try to do is you need to think about, well, we need a strong password. But you have to make sure this password is developed in a way that can't be easily guessed. Okay? So what makes a good password? So I'm going to walk you through several examples here. All right, well, first, before the examples, you want to choose a password that is at least 8 characters long. Now, some websites will say 6 characters. Honestly, that's not very strong. What some people do will have like 2 or 3 different common passwords. There's the short, easy one that they don't really care who gets into it. And then there's a longer one for more important things, and then maybe even a third one that's very, very difficult to guess for critical information. But I would recommend at least 8 characters. It should be a mix of lower and uppercase characters, numbers, and special characters. So special characters include like the £, the $, ampersand, parentheses if it takes it, dashes, underscore, those types of things. The more you can mix it up, the more random it is, the better. That being said, it has to be easy to remember, so you don't have to write it down. Because guess what? If you write it down, anybody can see it and use it. Okay? You might say, well, it's in my desk. Who's going to look at my desk? Well, a friend could walk in, look in your desk, or you might accidentally throw it in the trash, and then the trash goes out to the dumpster, and your neighbor goes through your trash and finds your password. You think that's that difficult to do? It's not. You think people don't do it? They do. In fact, that's a big issue that a lot of businesses have to worry about, is people within the business that write down their passwords and then throw that into the trash. Because guess what? When you throw the trash out to the curb, it's considered to be abandoned property. And if it's abandoned property, anybody has a right to go through it. Think about that for a minute. All right. Don't use dictionary words, but, and there's ways around this. You can use concatenations. You could use a dictionary word, like if you mixed capital letters in, or if you somehow switched, instead of using like the letter I, you use the number 1. And you can mix it up like that. You can use concatenations, abbreviations, acronyms, mixed with the letters and special characters. Okay, so can be a very good strategy. So let's take a look at some examples of what's good, what's not so good, and think about how you can write good passwords. Right? So let's say you're the president of the United States. Right? Obama would be a very bad password in that case. All right? Miley98 is only marginally better. A good hacker could guess this or use a dictionary attack to figure it out. And Miley was Obama's eldest daughter, and she was born in 1998. Okay, it wouldn't take long. A good hacker could guess it. A dictionary attack could probably even figure it out in less than a minute. Okay. So here might be a pretty good example. So here I have a Barack number 44 ZERP. Okay, so you see his last name. I threw in a mix of capital letters. I have a pound sign. He's the 44th president. Well, ZERP is actually prez for president spelled backwards. So by doing that, you have a nice mix of lowercase, uppercase, special characters, numbers, but it's easy to remember. You know, Barack is the 44th president, right? Now, ideally, a random is the hardest for any password guessing software to figure out. So I just typed this in. I had a random password generator who created this password for me. T, capital A, U, 3 at CIA star F02. But can you remember that? Maybe you can if you apply some sort of thought. So you can say, well, TAU, that's tau, that's the Greek letter T. 3 at... looks almost like sci-fi. So maybe there is Star Trek 3, Star Trek at 3 o'clock on Sci-Fi Channel in 2002. So I just kind of put together and tried to make some sort of story around these letters to help me remember the combination. And so if you can do something like that, it can be useful. So you have a random combination and still make it memorable. A good way of coming up with something is use the first letters from a phrase that might appear random. So here's an example. IPATTFOTUSOA. And I'll let you guys try to figure that out. What phrase is that from? Okay. It's a common phrase. All of you have heard this phrase before, probably many, many times. Do you see it yet? I'll give you a hint. At the end, USOA, United States of America. So what phrase ends in United States of America? How about, I pledge allegiance to the flag of the United States of America. Now, but you're looking at these letters, and you're like, this is a bunch of randomness. I don't know what the heck that is. Well, that's what's good about that, is it does appear random, but it's memorable, okay? So, for example, you might take your favorite song and take, like, the first letter of the first line of the song, okay? So now you have a series of letters that you can put together. Or you might even take the full words, maybe the title of the song, and instead of taking everything as is, you can change a few of them out and say, instead of, like I said, instead of an I, you change it to a 1. Instead of a O, you change it to a 0. Now it's mixed up in such a way that it makes it much more difficult to guess it. Okay, so there's little things you can do like that to take any password that's still memorable but also very difficult to guess. All right, let's move on. All right, so database security. There's actually a relatively new type of security issue that's developed online because of this. Okay, it's called the SQL injection attack. And essentially, right now we have all these forms, online forms, that allow you to enter information that then is submitted to a database. Okay? Well, where's the problem? So let's take a look at this line and see if you guys can identify it. So here's a SQL statement. So those of you who have taken a database class, hopefully this will ring a bell. We're doing select star, so select everything from the table called users, where name equals, and then we have them enter our username. Okay. What would happen if instead of a username, they typed in this? So plug this in to where it says username. Now think about what that would do. What would that look like? This is the code. Select star from users where name equals nothing or 1 equals 1. Well, when does 1 equal 1? All the time. Okay, so select star from users where name is always true, where everything is true, which basically returns all the users. So instead of a person just returning information about one particular user, their username, now it has to return everybody's information from all the users. You see where this can create a problem, right? Okay, so instead of just one return, it brings back everyone. But consider this much, much more nefarious. Instead of username, they typed in this big, long text. Okay? And what does that make for the SQL statement? Select star from users where name equals A, semicolon, drop table users, select star from user info, T equals T. Look what just happened there. They've actually put in a drop table. They have deleted your table of users. And then they said, let's bring back from another table called user info, bring back where T equals T, which is always true. So it brings back all the information about the user infos. Again, these can get very nasty because they can screw up your database. And maybe they don't get the database name correct the first time, but they keep trying different variations of this until they get it right. This will actually send 3 SQL statements to the database, and each one will be executed. Very, very ugly for what they can do. Now, especially if you're using a program, let's say like WordPress or Joomla, where the database schema is well known, then it gets even more dangerous, right? So how do we protect against this? Well, this is where, as a coder, as a developer, you have to learn techniques to avoid the SQL injection attack. So for example, here's what you can do in PHP. So I have a query I'm developing. I can put in a function called MySQL real escape string, which will double check to make sure it is well developed. It prevents these types of issues where they try to put in extra SQL statements in there. Okay, so MySQL real escape string. And then you can submit the query safely without having all this other junk in there. All right, and each one of the different server-side programming languages is going to have these mitigation techniques. The important thing is that you learn how to use them well. All right, server-side security. So the third one we're going to look at is overwhelming the server. Okay, in other words, just sending so much information at the server it can't work. Common type of doing it, the common variation of doing this is called the buffer overflow. So if you think about what is a buffer, you can think of a buffer as essentially a holding cell for incoming traffic. Okay, and it's designed to allow the server to process things as they're coming in without one at a time, basically. Okay, so there has to be some sort of means of catching incoming traffic and then sending it on to be processed. Right? So if that's what a buffer is, what does it mean for it to overflow? That means a buffer is made to catch things, but it can only catch so much. Okay, it's kind of like your hands are only so big. They can only hold so much. Or if you're using a spoon, your spoon can only hold so much. Well, a buffer overflow attack essentially sends so much information to the server at one time that simply cannot handle it. The buffer overflows and the server gets too much information to deal with and it ends up crashing. Okay? Or what happens is that another variation of that is the buffer is so full of illegitimate requests that legitimate requests can't get through. So a denial of service attack is a type of overflow attack. Okay? Essentially, denial of service is when you send so much information to so many requests to a server that it can't deal with it. Okay? Oftentimes means what are called zombie machines, which are basically machines that have already had malicious code installed on them, and then this malicious code is all triggered at the same time. So there's a clock on them, and they all launch at the same time to attack the same one website. And they keep sending requests to this one website from many, many, many different zombie machines, sometimes thousands of these different zombie machines, are all sending as many requests as they can to this one centralized website. The website can't handle all those requests and essentially makes it impossible to deliver web pages to legitimate requests because they're so busy handling all these illegitimate requests, essentially denying service to the people that want to use it legitimately. There's also something called a mail bomb, which is very similar to the denial of service attack, where you send so much email, that it creates, it explodes on the server and it can't deal with it. And then email viruses and worms we already talked about. All right. Stopping denial of service attacks. Basically, you have to do this at the zombie machine level, or you can't do it. Sorry, the first step is to stop it at the zombie machine level. So computers that have been commandeered by cyber criminals. How can this be? This actually happened at a company I worked at, where we had a server who became a zombie machine, and our internet service provider called us to tell us that our machine all of a sudden started sending out thousands of messages every second. And it was such a huge spike in traffic coming out from our server that it got their attention and they contacted us, right? So you need to scan for vulnerabilities and then also set and enforce security policies to prevent these types of machines from being taken over. And at the ISP, monitor and block traffic spikes. Now at the victim's website, what you want to try to do is create backup servers and network connections. So if one server gets taken down, you can pull another server online quickly or have one online ready to go if one server has been stopped. Okay? So there are techniques for getting around this attack. All right, moving on. More server-side security. The last major problem is looking at, I shouldn't say the last, this isn't the last, there's lots of them, exploiting holes and bugs in the server itself. And I shouldn't even go beyond that, not just the server, but also the software that's installed on top of it. For example, you might have PHP installed. There can be security holes built into PHP. You want to make sure those are blocked as well. You fix by using a good firewall, making sure you update frequently. And for those of you who don't know how a firewall works, I suggest you read up on it. Okay? I'm not going to spend a lot of time talking about it here. Essentially, it's just it can be either hardware or software that's designed to prevent traffic from getting in, except for approved accounts or approved ports that will have certain types of information in and out. Other general server security issues. You can have various levels of security codes, including a multi-level password system. So there might be one password for the server, a different password for the database, and a different password for the FTP login, and a different password for the website login. You want to have multiple different levels. You want to make sure all of these passwords are encrypted. You can even get very sophisticated and start using smart cards with microprocessors to access these systems. So something physical you have to carry on you. Okay. You want to make sure you back up your files, web server files. If your website does get hacked, you want to make it as easy as possible to replicate what you do. Now, I'm doing that right now for you guys. I back up your web pages every night. I take all the files, I back them up to a local hard drive. So if anything happens, I can easily recreate what you did. You want to have system security monitors that are constantly checking for any problems, any unauthorized use, fraud, destruction, any of that. All right. If you have computer failure, which does happen, sometimes more often than we like to admit, can be man-made or natural computer failures. There are things organizations can do to ensure continuity. In other words, they want to get back up as quickly as possible. You can either install stuff to prevent computer failure or minimize its effects as much as possible. You want to set up preventative maintenance to prevent as much failure as possible. But you also want to try to develop a disaster recovery plan, which can include arranging backups and even much more. All right, and we'll talk about disaster recovery plans more in just a couple slides here. Okay. Fault tolerant systems. Okay. So we said we want to try to create a system that, if it has problems, it's easy to bring back up, right? So fault tolerant systems are systems that have redundant processors, peripherals, and software that provide one of three levels of capabilities. Okay. There's the failover capability, to back up components in the event of a system failure. So essentially, it's a backup. If your site goes down or if a server goes down, you immediately switch over to this new one, and bam, you're ready to go. Okay. There's a fail-safe capability where your computer system continues to operate at the same level, even if there's a major hardware or software failure. Okay. So it can still do so. Now you can think of this as sometimes if my computer gets turned off inappropriately, it'll ask me if I want to boot in the safe mode. Okay, that's kind of a similar concept. From a Windows perspective, that safe mode idea. All right, so a fail-safe is a capability a computer system continues to operate even if there is some problem. Okay. And then there's the fail-soft capability, where the computer system continues to operate at a reduced but acceptable level in the event of a system failure. Okay. And so sometimes what you need is multiple levels of computers working together to make this happen. And the key is, and this gets very sophisticated, types of network administration and server administration. Nothing we're going to get into in this class, but just know that these are the types of things you have to deal with, even when you're dealing with web servers, because these are things that you want to have up and functioning all the time. So you want to try to create these capabilities to continue your web server, the website. All right, what else? Make sure you upgrade software and install patches. I would probably put money on it that 90 to 95% of break-ins of computer systems happen after a software or hardware manufacturer announces a software patch. So think about that. Generally speaking, what hackers will do, they will watch for software patches that come out. Not everybody installs those patches right away. what they do is they then take the knowledge, learn from the patch announcement, and use it to break into websites that have not installed the patch yet. And sometimes they have a day, sometimes they have months, if not a year or more, between when these patches are applied. And they use that time to get themselves inside of a website or inside of a server and to do all kinds of damage. And I mean, you got an entire year, there's a lot you can do. All right. So what can we do to help make sure these patches are and upgrades are done on a regular basis? Basically, you want to have IT perform a security audit on a regular basis, which is where they review and evaluate whether proper and adequate security measures and management policies have been developed and implemented. Okay? Have they been implemented? And so here at ECU, they actually did this recently on our server that we use for our class. And they actually came up with some critical issues. These have been fixed, but what it did, and you'll notice if you look at that list, so they have various severities of critical, high, 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 and then the name of those, all of them from high on up, were PHP related. What would it take to fix it? One thing I had to do. I had to update my PHP installation to 5.3.16, and then everything was fixed. Okay. That's all you have to do sometimes. But it's important to do these audits. So this is actually the results of an audit. And it told us that they had these major issues. And all I had to do was go in and find the solutions to them and fix it. Okay. That's what needs to be done. And so the issue, though, came about because I didn't install a patch or the latest upgrade on the PHP version. Okay. And but that basically happened because a lot of these updates came across during the summer, and I wasn't here during the summer. Certainly wasn't using it for class during the summer, so I had no reason to update it. Okay. However, that does get some vulnerabilities on the server that someone could have taken advantage of and hijacked our system if I hadn't been careful. All right, so very, very important that you do these types of things on a regular basis. All right, coming back to disaster recovery plan. Well, what is that? It's essentially a formalized procedure to follow in the event of a disaster. Okay, and this can be, again, a man-made disaster, or a hacker breaks into your system, or it can be a natural disaster, whether it's a hurricane, a blizzard, a flood, something, power outage, something that creates a major, major problem for your business. Okay. What are the types of things you have to deal with? Include which employees will participate, what their duties will be, what hardware, software, and facilities will be used, the priority of applications that will be processed. So in other words, what's most important to get back up and running first, second, third, those types of things. Okay? And use of alternative facilities if that's possible. Okay? In fact, a lot of disaster recovery plans now specify that we're going to, so let's say we have a flood, you may not be able to get your own computer back up. But do you have a fail-safe or do you have a secondary system in another city that you can use? Okay, that's becoming far more popular recently, is doing this. Okay, you have backups in different cities. If there is a disaster, you can easily move to that new city, at least for your software or your systems. Okay, now the people itself, then that may be an entirely different issue. So an offsite storage of the organization's databases, and with a summary of that is all of your recovery plan has to include this. Now, it's not this enough to have a plan. Not only do you have to find which employees will be doing which stuff to fix what hardware and software and facilities, the employees have to know what to do in these situations. So it's sometimes good to practice your recovery plan, to put it into effect, to make sure people know how to actually do the things that are said that need to be done. There's a lot that can go into this doing a recovery plan. But you make sure it's not just something that somebody wrote down 5 years ago, and then everyone's forgotten about it. Okay, that doesn't do it look good. All right, so summarize. Well, here's the big thing, okay? Technologies, especially on the internet, continually evolve. So the possibility of internet cybercrime really have only just been basically just started to look at the problems, okay? It just started to scratch the surface in what the technologies can do. So there's some issues that I know will crop up over the next 5-10 years that we don't have today. But there will be new things that we have to worry about. So you have to stay on top of these technologies and the security issues that develop, okay? So constant research is a necessity in this area. Second, effective security management minimizes the opportunities for cybercrime. All right? The goal should be not how to fix the problem once it arrives, but how to avoid the problem to begin with. You don't want your server to come down and break, and so the website is gone, even for an hour. You want to have systems set up and in place and working to avoid any of those types of issues from the beginning. So security management is where you want to put your effort and your time. But then it's important for you as web developers to understand both the needs and the vulnerabilities of clients and servers. And not just the vulnerabilities, but what are some of the solutions? And hopefully I've given you a peek into both of those. What are the biggest problems, and how can we fix them? From looking at channel security to malicious code that can be found on websites, to malicious emails, to denial of service attacks, to oh man, my brain's going numb on me here now. And to the other server side issues, right? Yeah, like my little comp out there. To the other server side issues that you have to be paying attention to how you can protect your system from any type of database database attacks, or any attacks under the web itself. All right, but that's all we got for today. So catch us again when we get into chapter 11, and until then, have a great day.